Hello everyone, this is our IVP project Underwater Image Enhancement. And these are our group members Abhay Mishra, Charu Chandra Joshi, Falgun Soni, Prakhar and Sai. And this is our problem statement which states underwater images find application in various fields like marine research, inspection of aquatic habitat, underwater surveillance, identification of minerals and more. However, underwater shots are affected a lot during the acquisition process due to absorption and scattering of light. As depth increases, a longer wavelength get absorbed by water, therefore the images appear predominant bluish green and red gets absorbed due to higher wavelength. These phenomena result in significant degradation of images, due to which images have low contrast, color distortion, and low visibility. Hence, underwater images need enhancement to improve the quality of images to be used for various applications. And now handing over to Sahil.
So now we can see the some underwater images. These are the three images we can see. The distortion in this image we can see. These are the methodology diagram where we can take the input images and uh, we do the color correction of the input images uh, and after that we can contrast the enhancement of that images, global histogram equalization. Now we do the image sharpening, unsharp masking, and after that we do the output enhancement image. So now we'll talk about the composition of either RB or R challenges. Splitting the image into RG and V component, and second one the get maximum and minimum pixel value, then convert to array normalization the pixel value to range 0 to 1, now getting the mean of each channel. After that compensate the red and blue channel, compensate the red channel, create the composite image, plotting the composite image.
As discussed earlier, this is the original image and this is the comparative red-blue compensated image. Now moving on to gray world algorithm. The gray world assumption is a white balance method that assumes that your scene and on average is a neutral gray. Gray world assumption hold if we have a good distribution of colors in the scene. Assuming that we have good distribution of colors in our scene, the average reflected color is assumed to be the color of the light. Therefore, we can estimate the illumination color cast by looking at the average color and comparing it to gray. Gray world algorithm produces an estimate of illumination by computing the mean of each channel of the image. One of the methods of normalization is that the mean of the three components as illumination estimate of the image. And therefore, this is the compensated image and compared to the white balanced image.
Contrast enhancement, global histogram equalization. Histogram equalization is a computer image processing technique used to improve contrast in images. It accomplishes this by effectively spreading out the most frequent intensity values, that is, stretching out the intensity range of the image. This method usually increases the global contrast of images when its visual data is represented by close contrast values. This allows for areas of lower local contrast to gain higher contrast. Unsharp masking. Unsharp masking is an image sharpening technique first implemented in darkroom photography but now commonly used in digital image processing software. Its name derives from the fact that the technique uses a blurred or unsharp negative image to create a mask of the original image. So here is the original image. This is white balanced image, and here this is the sharpened image.
The last step of our methodology is fusion. We have used two fusion techniques. The first is averaging based fusion and the second is PCA based fusion. Now I will be going through the steps done to achieve fusion. First, splitting the image into R, G and B components. This step we have done in almost all the previous methodologies discussed. Then we converted it to column vector, got the mean of each channel, created a 2 times size array where each column represents each image channel, subtracting the respective mean from each column, finding the covariance matrix, finding the coefficients for each channel which will act as weight for images, calculated the pixel value for the fused image of coefficients, created the fused image. As you can see in this diagram, first we used the sharpened image as input, then we created the contrast enhanced image, and after that we used the PCA based fusion technique to create the PCA fused image. Now I will be going through the results. You can see here in these two pictures, the first photo is the deep water photo, and then through our technique we enhanced it. Thank you.